Okay, hello everyone. So this is the second part of determining amplitude, period, phase shift, and vertical shift. And unlike in the previous video, we will focus on relatively simpler problems, but we will demonstrate tangent and secant. So this is different from the cosine and a little bit different from the cosine and the sine. Okay, so as you can see here, the basic trigonometric function tan x, this is its graph. As you can see, it has a period of pi, like we know that it has a period of pi, right? So it is actually uh, if you look at the graph, this is actually uh, from negative pi over 2 to pi over 2 here. So this is all in all, the period is pi. And then it is from the asymptote on each side. As you can see, the x is equal to negative pi over 2 is an asymptote here, as well as the x is equal to pi over 2. Okay, so if we have a trigonometric function, let's say y, let's use another color. Let's use another color. Let's say we have y is equal to 2 tangent 0.5x, or let's just use a 1/2 x. Okay, so what is our amplitude here? So our amplitude, actually for tangent, as you can see, there is no amplitude because the range is from negative infinity to positive infinity. Okay, so we can only find the period here. So the period is actually, you can calculate the period using the same formula. The only difference is that we need to use pi because this is the normal period of the basic tan x divided by the absolute value of our b, which is 1/2, right? So this will be equal to what? So this will be then equal to 2 pi. Okay, so let's take a look at its graph. So it says that the period is 2 pi. So is it correct? So as you can see here, it is indeed 2 pi. As you can see here, it is from negative pi to pi. So all in all, that is 2 pi. Okay, so let us proceed to another basic function, which is the secant x. As you can see here, the graph, it's the same thing. This also has no amplitude because as you can see, the range is from um, and as you can see, the for the basic function we have here, it includes positive 1 to positive infinity, and as you can see here, it is negative 1 to negative infinity. Okay, so what we can calculate here is the period. Okay, let's take a look. So what if we have y is equal to secant of pi x? Okay, so we actually have a b here. So our b here is pi, right? So b is pi. Okay, so how do we get the period? So the period is equal to, so the secant, so as mentioned in the previous video, the secant has a normal period of 2 pi, right? So 2 pi all over the absolute value of pi. So we can cancel this out. We will get 2. Okay, let's take a look if it is actually 2. Okay, so it is 2. So as you can see here, from 0, let's use another color, from 0 to positive 2. Okay. So instead of from 0 to 2 pi here from the original, okay? So that's it for this video, and the same transformations that we did in the previous, same apply here. So the only difference is that these particular functions have no amplitude, but the shifting are still apply. Okay, so that's it for this video, and I hope that you learned something that you can use to answer the exercises. So see you in the next ones.